getting back to this particular map tool, or this particular map message configuration we have here, I can go to the Tools option, and one of the options is to delete everything, but the other is to access the encoder system. If I click this encoding menu, we'll get a handy dialog that shows us kind of the current contents of our map message, the various data we have in it. And we'll get an empty spat message due to the way the system interacts with the ISD message mentioned previously. But since we're only worried about encoding map messages today, we don't have to pay any mind to this particular warning. So here we'll see the raw kind of logical data of the map message as we have it now. And when we finish our encoding, we'll get the abstract syntax notation version 1 encoding as a logical format there. And in this particular text box, we'll get the unaligned packed encoded hex values that we can use to upload to a roadside unit for broadcast. That will be the data you directly want to use over the air. On this screen, we have a couple of options. We can select the message type, and we can select the node offsets. For our message type, we have a couple of possible choices. We have the ISD message. We have the raw map contents, not suitable for broadcast, but if you wanted to do some analysis on it, it would contain less data. The message frame plus map object, which is what we are going to recommend we use. It is the J2735 full message ready for broadcast. And if we had included any sort of spat sample data with our map message, we could generate the spat message, the frame plus spat, which is the analog of the frame plus map, and the spat record portion of the ISD message. For this particular case, as mentioned, we're going to select frame plus map because it is what is available for ready broadcast over the air. The node offsets describe the relationship between all of the points in a lane. In the explicit encoding, we're going to be using full detail latitude, longitude points for every point in each lane. All of our reference points that we inserted will be expressed in their highest possible detail, which is going to produce a quite large map message, but may prove useful if you need the data to be more human readable or easy to consume for debugging purposes. Standard is similar, although lower resolution. It's a compromise. And then compact and tight refer to offset-based encoding methodologies, where rather than representing each point as their full latitude, longitude value, they represent them as offsets from the reference point in your intersection. Compact is going to use the smallest offset size that will work for all of your points. So it'll pick one particular offset size that it can use comfortably to fit every offset that it needs to fit in your message, and then use that globally. The tight encoding will select that value optimized at every point in your map message. So it's going to produce you the smallest encoding that we can do. And I'm going to recommend using the tight encoding for all of your uses, simply because it produces the smallest possible message. So we'll select the tight encoding, and then with that all set, we can go ahead and click Encode, and now we see that these two text boxes are full of the data that we just used, or that we just mentioned. So this is going to be the ASN1 data, the logical, human-readable, structured data. And then this contains that Uber-encoded hex data that you could copy and paste and upload straight to your roadside unit for use with its store and repeat broadcast mode. We've done this several times here at the Stoll, and it seems to work out pretty well for us. So with that encoding done, you can simply reach into this text box, select everything, and copy and paste that out into whatever other tool you would like to use to load that to your RSU. It might be a different upload mechanism depending on the manufacturer or vendor of RSU, but they should all support functionality to load these Uber-encoded messages. That concludes the demonstration of the encoder. I have one last tool that I would like to show off on the ISD, or on the connected vehicle service website that kind of goes hand in hand with the encoder, which is the Message Validator. So I'm going to copy all of this binary data out of the encoder, and then I'm going to navigate away from the ISD/map tool and back to the home page. If you scroll down on the home page, you'll see this Message Validator section. So if you click View Tool, it'll take you to the Message Validator, and here's where you can paste or upload DSRC message for validation to see, make sure that you're encoding processed correctly, or if you have some other parser you're attempting to use to make sure that you both arrive at the same result in kind of the expected fashion. So we're going to validate our map message by coming up here to message type and selecting message frame, since that's the base J2735 message we'll be using. And then we're just going to paste our encoded map message right into this text box. And once that's done, all that's left to do is to click Validate, and now we can see this parsed and validated message. So it turned green to show that our message validation was successful. It prints the particular type of message it was referenced as, or recognized as, in this case, a message frame object. And inside that message frame object, we can see the map data that we just asked it to encode. And this output here should be the same as the ASN.1 output we saw in the previous step with the encoder. Now, in the case that this hadn't worked, for example, say we malform our map message by deleting several bytes in it, and then we click Validate, you're going to get an error message explaining why the parse failed, and it's going to turn red to show that the message was not detected as valid. So that concludes my demonstration of the Message Validator, and I will jump back to my presentation for a quick second, just to give a brief summary of the encoder and validator. So there's lots to take in on this slide, but it's mostly what I had previously explained. The different message types, ISD being used by the Safety Pilot program primarily to unify SPAT and MAP. The map message, map plus frame, SPAT, and SPAT plus frame. And we recommend, as is bolded here, the map plus frame encoding for your production needs. And then when it comes to node offsets, the explicit, standard, compact, and tight encodings. And we just recommend using the tight encoding simply for size efficiency of your message. It's going to be easier for your over-the-air broadcasts. And that largely brings us to the end of this portion of the presentation. We've got some contact information here for both myself and Deborah Curtis, the Government Task Manager associated with this particular effort. And below you'll see the contact information for the Connected Vehicle Support Services, our toll-free hotline, and our web-based ticket support system. If you have any issues, please feel free to reach out to those resources, or any questions or concerns or enhancement requests, please do let us know. We're monitoring those very closely. And before I hand this off to Q&A, I would like to very quickly walk through just the user interface for that ticket system. Here's a screenshot from that web service. So if you have any particular needs or service requests or questions, you'll see at the top right there's a red box around the new service request field. Please feel free to follow that link and enter any information that you might feel is relevant there. And down at the bottom, you'll see under Useful Articles, map/TIM tool documentation. Now the TIM tool is not something we've covered here today, but there is documentation under there for the map tool as well. And if you're interested in the TIM tool, that may be of interest for you to read as well. So I'm going to leave this slide up for a bit, I guess, while we go to Q&A, but I think that concludes my section of the presentation. So as far